guys, welcome to 75 day lead code coding challenge, and today we are going to solve our next problem statement, evaluate division. So let's start. You are given an array of variable equation and an array of real number values where equation I is equal to ai comma bi and values I represent the equation ai divided by bi equal to values I. Each ai or bi is a string that represent a single variable. You are also given some queries where queries j is equal to cj comma dj. Represent the jth query where you must find the answer for cj divided by dj. Return the answer to all queries. If a single answer cannot be determined, return -1.0. Note the input is always valid. You may assume that evaluating the query will not result in division by 0 and that there is no contradiction. The variable that do not occur in the list of equation are undefined, so the answer cannot be determined for them. So we have given a equation. The values, what is values? It is a divided by b. So a divided by b is 2.0, b divided by c is 3.0, and we have given a queries for which we need to find the answer. So a by b is equal to 2.0, b by c is equal to 3.0. So what is a by c? What is b by a by e, a by a, and x by x? So this is the output for this. So let's discuss how we are going to solve this problem statement. So I have written the test case here. Let's say for first the equation is given a by b, b by c. So a by b is equal to 2.0 and our b by c is equal to 3.0, right? You can just correlate it here. So a by b is 2.0 and b by c is 3.0, and now we have given these queries and we need to find the answer. So what would be a by c, the first query? So we can simply place it. So a is equal to 2.0 of b and b or c, you can say b by 3.0, right? Now you can place a and the value of c here. So a is equal to 2.0 of b and c is equal to b by 3.0. This is the basic math only, and you can cut b by b, and what is the answer? 2.3 into 3.0, so it is 6.0. This is our output. The second query is b by a. What is b by a? We can say a is equal to 2 of b, so I can write 2 of b. I can cut b by b, so what is 1 by 2? It is 0.5, right? And what is a by e? For this, if we cannot determine the answer, we need to return -1. For a by e, if you can see, we do not have any variable with the value of e, so we can return -1 directly because we do not know the value of e. This is also solved. What is a by a? So any number dividing by itself is always 1, right? And x by x is not a value that we know, so it is, the output is -1. So I hope you got the solution, but let's try how we can solve this problem using data structure. This is I solved using only a math, but we need to understand how we can solve it using code. So let's discuss that part. So let's delete all this, we do not need it. So this is a graph problem. I know you are not able to get it, but it is hard to find, but it is a graph problem. We can create a graph for this equation. So suppose we have a node A, we have a node B, and we have a node C, right? So let's make it a directed graph. So A by B. So we are saying if there are two nodes, n1 and n2, and we have given a value of n1 by n2, right? So we are saying it is a weighted directed graph. We can create a weighted directed graph n1 and by n2, and the value for this will be n by n2. This is the value. and if we make it opposite direction, we will opposite the value, so it will be n2 by n1. So let's discuss it. So a by b, let's make it a directed graph. So a to b, the value of the weighted directed graph is 2.0. So if we are going from, so let's see like this. If we are going from a to b, the value is 2.0, and if we are going from b to c, the value is 3.0. This is the weighted directed graph. But now let's see, if we are going from b to a, if we are going from b to a, we can say it is 1 by 2.0, and if we are going from c to b, then the value is 1 by 3.0. So we just reciprocate our weighted value. So from a to b, our value is 2.0. From b to c, it is 3.0. But if we are going from c to b, we reciprocate the weighted value 1 by 3.0. And if we are going from b to a, we reciprocate it 1 by 2.0. So this is the graph. So let's now try to solve the query a by c. What is a by c? If we go from a to c, what is the output if we go from a to c? So what we are going to do, whatever weight we are getting in the route, we are going to multiply all the weight. So whatever route we are going from a to c, from source to target, whatever route we are going, we need to multiply all the weight. We need to multiply all the weight. So we are going from a to c. So let's take it red marker here. We are going from source is a, target is c, and we need to multiply all the weight. So first we will go from a to b, then from b to c. So a to b, the weight is 2.0, and from b to c, the weight is 3.0. Let's multiply this. The output is 6.0, and this is the correct output. Now let's solve the second equation, b by a. So now we need to go from b to a. Let's say b to a. So from b to a, the weight is reciprocate of the weight. So from a to b 2.0, but from b to a it is 1 by 2.0. So for the second case, the answer is 1.2.0. So it is 0.5. So this is also correct. Now let's say a by e. So there is no node with the value of e. For such cases, we simply written -1. There is no node in our graph with the value of e. Now a by a, node visiting itself is always 1. You got it, right? Number dividing by itself is 1. If a node visiting itself, the source and target are same, source is equal to target, then in that case we will say the answer is 1. The last case, x by x, there is no node with the value of x, so we return -1. So I hope you got the answer. First we need to create a graph. All the value for a, b, b, c, we create a node in the graph. Then we have given a values. So from a to b, we have given a weighted graph value 2.0. So if a to b is 2.0, then from b to a it will be 1 by 2.0. If b to c is 3.0, then c to b it will be 1 by 3.0. And what we have to do, if we are visiting from source node to target node, we have given a queries, and we are visiting from source node to target node, we need to multiply all the weight. So when we are visiting from a to c, we simply multiply all the weight in the route. So when we go from a to b, it is 2.0, and when we go from b to c, it is 3.0. We simply multiply the weight, and we got the answer. Okay guys, let's jump to the coding part. First we need to create a graph for the equation. So we can say for every unique string value, we will create a node in the graph, and let's describe all the node in the graph with the value of integer value. So suppose our count is start from the value of 0. So a can point to a 0 integer, b can point to a 1 integer, and c can point to a 2 integer. So again we can create a node in the form of integer 0, 1, 2. So 0 is a, 1 is b, and 2 is c. and we have stored it separately. So first create a map store index. First part is done. Second, we need to create a directed graph. So we have the node, then we create a directed graph. A is pointing to B and B is pointing to C. So it means 0 is pointing to 1 and 1 is pointing to 2, right? So from A to B, the value is 2.0. From A by B is 2.0. So it means A 0 to 1, it is 2.0, and from B to C, it is 3.0. So from 1 to 2, it is 3.0. But we have said from source to target, if weight is W, so from target to source, it will be 1 by W. So from 0 to 1, it is 2.0. So from 1 to 0, it will be 1 by 2.0. And from 2 to 1, it will be 1 by 3.0. So we need to reciprocate the weight value. So we need to create this directed graph. So create directed graph. Then what we have to do? We need to do a DFS traversal for all the queries. So we have given a query to do DFS traversal from source to target. So what is our source? It is our query. So A comma C. So for A comma C, A is source and C is target. So we are going to DFS traversal from A to C. And what we are going to do doing the DFS traversal, multiply all the weight. Multiply all weight. So from A to C, A is our 0, C is our 2 node. And when we move from node 0 to node 2, we need to multiply all the weight. So from 0 to 1, it is 2.0, and from 1 to 2, it is 3.0. So we multiply it and the output is 6.0. So we need to do DFS table again and again from source to target for all the queries that are given. So we need to implement this 4-part. Let's do the coding now. First, let's create a map to store the index. Let's create a separate method for it. Public static void fill your map, fill map. To create a map, we need to have all the equations. So list of string and equation. Define your map, string comma integer map. So we are creating this map A, B and C. So for this test case, A will point to 0, B will point to 1 and C will point to 2. So let's iterate over your equation. List of string so now there are two nodes A and C. So get a n1 value, equation dot get 0, get the n2 value, equation dot get 1. Now store it into your map, but there can be a duplicate node value also. There can be multiple A also. So for this A and B, there can be again equation came where A is again where A is again is in the equation. So we need to handle that case also. So if the map already have the n1 key, the map dot key set dot contains n1. If map do not contain our n1 value, we need to create an index for it. So map dot put, let count the number of nodes. So n is our number of nodes. Create an index for the n1. So n1 comma n. Let's say count n1 comma n, and we have create stored one node index, so we are going to increment our count value. Same we have to copy paste for n2 also. So just copy paste it here and do it for n2 also. Return your number of node count also. It will be, we will be required further in the code. Let's say int. So we have filled our map. To create a map of type string comma integer map equal to new hash map equal, call your fill map method. Let's say n is a number of node, and fill your map, pass your equations comma your map. Now your map is filled. We need to do the second part. The first part is create a map to store index. Now the second part, create a directed graph. We need to create a directed weighted graph. So create your graph equal to, what is the size of your graph? You already have the value of n. This is the number of node, so n by n. Then we need to create our graph. So let's iterate over all your equation again. So copy paste this part here. Get your both value n1 comma n2. But instead of n1 n2, we can directly get the index also. So let's say n1 and n2 and directly get it from your map. So map dot get. So for this, so if you are passing a, it should return 0, and if you are passing b, it should return 1. This is our expectation. So map dot get 1. So now it is done. Now what we have to do, we need to create a weighted directed graph. So from 0 to 1, if it is 2.0, from 1 to 0, it should be 1 by 2.0. So we need to have this weight value also, right? And our weight value is stored in the value array. So this is our values array, and our weight is stored in it. So let's access our values array. So you can say index equal to 0 and double. This is our weight. Let's get it from our values array. Now we get the weight. Increment your index every time. So for a and b, we get a weight value, and then for equation b and c, we get a weight value, right? So if we are going from n1 to n2, we need our weight value is weight. But if we are going from n2 to n1, it is 1 by weight. This part we already discussed. So this is done. Our graph is also ready. So let's check. So our second part is also done. Now we need to write a logic to do the DFS traversal from source to target, and then we also need to multiply all the weight while doing the DFS traversal from source to target. So let's create a separate method for it to do the DFS traversal. So let's say public static DFS we need a graph, a source, target value. We can also say this is our current node that we are visiting. Current, and we are moving to the target node. We need to have the visited boolean array also, so that we do not go in the cycle. And at last we need a multiply value. So we are going to multiply all the weight when we are moving from source to target. So this is our DFS traversal logic. We can create a global variable also, static double our answer for the current query. Let's initialize it with the value of minus 1.0. And if our current goes equal to target, if the current node is equal to the target node, we know we have reached to the target node, then we simply assign the answer with the current multiply value. And we do not do the further processing, so we return from there only. Now what we have to do, we need to traverse to the connected graph. Sorry, we need to travel to the connected node. So fetch all the connected node. This is all the connected node from the graph. Pass your current node. Find all the connected node. Now iterate over your connected node. Now if the connected node is not visited, and also one more thing, node is only connected if the value is greater than 0, right? Because we have given the value of a by b and we are creating a 2D matrix. There can be a case where we have the default value of 0.0, but we do not want to process that node because it is not connected. So only connected node is if the value is greater than 0. So if the graph comma I have the value greater than 0, it means it is connected and it is not visited. Then we can say do the DFS traversal. Do the DFS traversal, pass your graph, pass your current node. What is the current node? It is I. Pass your target as it is, pass your visited boolean array, and pass your multiply. What is it will be your multiply? Multiply into current weight. What is our weight? Graph comma, we already have stored the weight, whatever is connect node value. So connect node I. So we have multiplied the weight, and when we reach to a target, we have assigned our resulted value to the answer. So our DFS logic is done. Now what we have to do, for every query that is coming, we need to do the DFS traversal from source to target. So integer, let's say list of string comma, iterate over all your queries. So for the queries, there are two values, node 1 and the node 2, source and target. So get your source and target. So src is equal to, so first let's get it. Src is equal to queries dot get 0. And src target is equal to queries dot get 1. Now one more thing, if the node is not in our map, if x and a, these are the value that is not in the graph, So if the source and the target node is not in the map, we need to return -1 for those values. So if the map do not so the map dot contain key set dot contains key src map dot key set key target. Your source and target key is in the map. Then only we going to call our DFS method. DFS graph, comma. Our current value is what is our source value? Get the index from the map. Map dot get pass your source, and what is your target? Map dot get pass your target, and then we need to also create a visited boolean array every time. So initialize your visited boolean array. Boolean of type visited equal to new boolean. Pass the size of the size of the number of nodes that are in the graph. So it is n. So pass your visited boolean array and your initial multiply value. So I am passing 1.0. This is our initial multiply value. This is done. If and at last, every time initialize your answer value with the map value of -1.0. We need to return our answer array. To create one more double equal to let's say array equal to new double. What is your query size? And we are going to store the answer every time. Array index is equal to our answer, and return your answer array. This is done. Our code is done. Now let's try to run the test case if it is working. We have some compile time error. Let's solve it. Map dot key set. Remove this part. And we do not contains and contains. Okay, this is connected node. Okay, we are getting a stack overflow error. What is the mistake we are doing? Yeah, we are not marking our node as visited. Mark your node visited, your current node, whatever you visited, mark it as visited. So now run it again. So yeah, our test case is failing. So let's check what we are doing wrong. So answer is we are initializing with the value of multiply. We are calling our DFS traversal graph. It should have the source and the target value. Answer we are initializing with the value of -1.0 every time. Uh, we are not, I think, increasing our index every time. So let's say index plus plus. So now run it again. So yeah, now our test case is working. Let's submit the solution. So yeah, our solution is also working. Quite a long solution, but yeah, finally it worked. Yeah, thanks for joining the session and let's meet tomorrow.